Greetings, welcome, dear audience, to our professional masterclass again. Yeah, today we have our Professor Dr. Rania Lampu to continue our research, design, and methods. Under today's topic will be sampling techniques, lecture number 12. For this, I would welcome Professor Dr. Rania Lampu from Greece again. Welcome, dear. Welcome.
Good evening. Good evening. Here from Athens, from Greece. From the Greek Ministry of Education, we have 43, 45 degrees this week.
Wow, so hot.
Yeah.
Horrible. I thought Malaysia is hot, but here not so hot, I think. Only
Yes,
13 plus. Yes.
It's tough. It's tough.
Madness, right? So hot.
Yes. Anyway, it gives me great pleasure to welcome you all to this session on assembly techniques. And whether you're conducting a scientific study or whether you're designing a survey or analyzing the big data, choosing the right sample is critical. Why? Because we rarely study entire populations. Instead, we rely on carefully selected subjects, subsets like samples, to draw conclusions that reflect the bigger picture. So today we will explore broad categories on sampling and techniques. And by the end of the session, you will have a solid understanding of when and how to use each technique and how your choice can significantly influence the validity of your research. So thank you for being here. Thank you, Elegant Higher Education, for giving me this unique opportunity to conduct this research series. Thank you, Dr. Estera, for the invitation. So let's dive in and explore
Yeah.
the world of sampling with enthusiasm and a critical mind. So welcome once again, and let's get started. I will share my
That's right. So,
presentation.
yes, please. Your slides. Yeah, it's we have here. I will add to the
No,
stage.
it's not this. It's not this. Sorry, it's not this.
I just edit. Yeah. Uh-oh.
Wait,
Not yet.
wait.
Okay.
Yes, it's. No, it's not visible yet. Can you see now? I don't know.
I can't see your slide. You have to upload. Upload your slide. You haven't uploaded yet.
I haven't uploaded.
Yeah. Just now you uploaded, but it didn't appear.
Right. I think now it's fine.
Yeah. Okay.
Can you see the change of slides also?
No, not yet. I just add to the stage, and I think it's taking time to load on the screen. Yeah, it's loading now. Okay, I can see the screen. Yes, you're moving. Good to
Still
go.
moving. Okay, thank you. So first, we need to start from conceptual understanding. What is sampling, and why is it important in research? Sampling is this process of selecting a subset called a sample from a larger group called the population to study and draw conclusions about the entire population. Already in the previous sessions, we have discussed a lot about sampling, and we have also mentioned some main categories. But today we will also explore more details, and we will focus more practical applications. So, why sampling is it important in research because studying an entire population is often expensive, is time consuming, or impossible. Sampling allows researchers to gather data more efficiently. A smaller group means data can be collected and analyzed more quickly, enabling faster decision making, so faster results. It's something that saves resources such as time, manpower, and equipment. So we talk about resource optimization. A well-designed sample can provide highly accurate insights about the population without the errors that might occur in attempting to reach everyone. And of course, results from a representative sample can be generalized to the entire population, allowing for broader conclusions. In fields like medicine or psychology, it might be, for example, unethical to experiment on entire population. So sampling allows for controlled, safe research. So what you need to know that the main types of sampling are this one, probability sampling, which includes random sampling, systematic sampling, cluster and stratified sampling. And on the other hand, we have a no probability sampling, which includes convenience, judgmental, or purposive sampling, quota, and snowball sampling. Here in the probability, every member has a known chance of being selected, and the no probability selection is based on no random criteria. And sampling, of course, is essential in research because it makes studying large populations manageable, efficient, and cost-effective, while still providing a meaningful and valid insights if it's done, of course, correctly. So what are the differences first between probability and no probability sampling? Here we can see a comparison table. In general, we could say that probability sampling is more scientific and more suitable for research needing high accuracy and generalizability. This is you have to have in mind. On the other hand, no probability sampling is quicker and cheaper, but less reliable for making population level inferences. So here you can see probability sampling has usually, every member has a non-zero chance of being selected. On the other hand, not all members have a non-equal chance of being selected. The first one is random, the other one is subjective or convenience-based. The first one is more likely to be representative of the population, the other one is less likely to be representative. Probability sampling has low bias. Why? Because of randomization. And the no probability sampling has high risk of bias. The first one, we said before, it's about high generalizability. And probability sampling, the results are less generalizable. And the categories that we mentioned before, we're going to analyze each one, all these details. The probability sampling is used in quantitative research and large-scale surveys requiring statistical accuracy. On the other hand, no probability sampling is used in exploratory research and qualitative studies or when probability sampling is impractical. So another definitions that we need to explore here to clarify is the difference between population, sample, sampling frame, and sampling unit. Population is the entire group of individuals that we want to explore. So here we try to include all elements that meet a set of criteria for our question. Second, the sample. The sample is a subset of the population that we try to observe and for which we try to collect data. So this sample is used to make inferences about the population. A sampling frame. What is a sampling frame? Is a list or database from which a sample is drawn. Ideally, it would include every member of the population, but in practice, of course, this does not happen. And a sampling unit is the single element or group of elements considered for selection of the sampling process. It is the entity from which data are collected. Let's give some examples. For the population, if you're studying the average income of all households in Canada, the population is all households of Canada. For example, a survey of 1,000 Canadian households drawn from all Canadian households. This is sample. What would be a sampling frame? A government registry of Canadian households or an electoral roll used to select survey participants. So this is a sampling frame, which is the difference between sample and sampling frame. A sampling unit, we can see an example in the case of household surveys that we're talking now. Each household is a sampling unit. So these are main differences through an example. So what are the advantages and disadvantages of using a sample instead of a population? Of course, this has several advantages because, as I said before, it's something which is cheaper, so cost-effective, it's time-saving. In many cases, it's impossible or impractical to access the whole population, for example, all people in the country. The feasibility and efficiency, because sampling allows researchers to focus on data quality and in-depth analysis rather than being overwhelmed by volume. And manageability, because data collection, cleaning, and analysis are more manageable with a small data set, of course. And this allows for quick decision-making because businesses or policymakers often need rapid insights which sampling can provide. On the other hand, what are the disadvantages? The sampling error, because a sample may not perfectly represent the population. This could lead to inaccurate or biased results. The risk of bias, because poor sampling techniques, for example, no random technique, no random sampling, can alter results and reduce validity. Findings, another case, findings from a sample may not always apply to the whole population, so especially if it's this small or non-representative, so limited generalizability. The lack of detail, sampling might miss rare events or characteristics that exist in the full population and needed for statistical inference. Results may be estimated and interpreted with uncertainty, often requiring confidence intervals, as we say, and hypothesis tests. So here we can see difference between sample and the population in terms of cost, of accuracy, and in terms of feasibility and data details. Of course, a sample may miss rare data, population captures, or variations. Now, we mentioned the first category before about probability sampling techniques, and this includes simple random. Simple random sampling is a method where every member of the population has an equal chance of being selected. It ensures unbiased representation and is often used when the population is relatively small and homogeneous. So what are the key characteristics? Each individual is chosen entirely by chance, the first one. The second is that the selection of one person does not affect the selection of another, so no bias. And this requires a complete list of the population. Let's take an example. Imagine a school that has 200 students, and the researcher wants to select 20 students to participate in a survey about study habits using this simply random sample. So what could be the steps here? Here we need to assign a unique number, 1 to 200 to each student. First one is this, assign a unique number from 1 to 200. Second, use a random number generator, like a computer program or random table or lottery method, to select 20 unique members. And third step, the students corresponding to these numbers are included in the sample. So what is the result? That each student had the same 1 in 10 chance of being selected. What are the advantages of this? That this eliminates selection bias, that it's easy to understand, of course, and implement, that results are statistically reliable if the sample size is adequate. And on the other hand, the limitation is that it's not practical, of course, for very large populations, and this requires a complete and accessible list of all population members. So in summary, we could say that simple random sampling is a fair and straightforward method to select a representative group from population, making it a foundational technique in research. Now, another type of probability sampling technique is what we call systematic sample. And systematic sample is a type of probability sampling where samples are selected at regular intervals from a list or populations. So this process involves usually the following steps. First, we clearly identify the group from which we want to draw our sample. So we define the target population. Second, we decide how many units we want to include in our sample. So we determine the sample size. Then we prepare a complete and ordered list of all elements in the population, which is what we call the sample frame. So list the population elements. Then we calculate the sample interval. We use specific formulas there. And we select a random starting point, choose a random number between 1 and k as a starting point. So select every kth element from the starting point, select every kth element of the population list until the desired sample size is reached. This is an example of this, the population size, the desired sample size, the sample interval, the random starting point, and sample elements would be like this. Now, how does this, now we have another type, the stratified sampling. And stratified sampling improves representativeness. First, we need to explain what is stratified. Okay, stratified sampling involves dividing the population into distinct non-overlapping subgroups, what we call strata. All these are based on one characteristic, age, gender, or income, and randomly sampling from each stratum. This could be equally or proportionally. So why this improves representativeness? Because it ensures inclusion of all key groups. It guarantees that even small or minority subgroups are represented in the sample. For example, you talk about university. In a university, if only 10% of students are international, simply random sample might miss them. On the other hand, stratified sampling ensures that they are included. So this is one reason. Second, by controlling how many individuals are taken from each subgroup, this avoids over or under representing certain groups, so reduces sampling bias. These estimates like means or proportions are more precise because each group is well represented, and this reduces sampling variability within each subgroup, and supports comparison between groups because data is collected from all strata. Researchers can compare different subgroups more reliably. Let's give an example. If a company wants to understand employee satisfaction and has 60% office workers, 30% factory workers, and 10% remote staff, then stratified sampling, in this case, ensures that each group is represented according to these proportions. This leads to more accurate and generalizable results than a single random sample might. So, stratified sampling ensures representatives by ensuring that the key subgroups, strata of the population, are proportionally included in the sample. Now, if we want to compare stratified and cluster sampling, here we can see the differences between cluster and stratified sampling. So we said that the stratified sampling is divided, the population here is divided into distinct subgroups based on specific characteristics. And we have a random sample which is taken from each stratum. On the other hand, the population is divided into clusters, and cluster sampling usually is based on geography or other natural groupings. And here, entire clusters are randomly selected. All or some members are surveyed. So what are the key differences? That stratified sampling ensures representation for all key subgroups. Cluster sampling reduces costs and improves convenience. Stratified sampling is divided into homogeneous strata. Cluster sampling is about heterogeneous clusters. Stratified sampling, we have here a sample taken within its stratum. Cluster sampling use sample entire clusters, but not individuals directly. We talk about entire clusters. And of course, stratified sampling is more representative of the population. And efficiency, in terms of efficiency, is more statistically efficient. The stratified sampling is more statistically efficient, and cluster sampling is less efficient statistically, but more practical logistically. Now, the advantages of stratified sampling and the difference between cluster sampling is that stratified sampling reduces sampling error, it increases precision, it ensures inclusion of all subgroups. On the other hand, a cluster sampling could be cost-effective for large spread-out populations. It is quicker to implement, useful when a complete population list is hard to obtain. And the disadvantages for stratified sampling is that it requires knowledge of all population strata. It can be complex to organize, and the disadvantages of cluster sampling could be that there is a risk of higher sampling error if clusters are not representative, and there is less precision and potential bias if clusters vary widely. So, to give an example, a researcher studying student performance divides a university into strata based on major, for example, science, arts, business, and randomly selects students from each major. This is a stratified sampling. An example of cluster sampling could be a researcher studying household income, selects a few city blocks, clusters at random, and surveys all households in those blocks. So when to use which? You need to use stratified sampling when you want accuracy and representation across subgroups, and you use cluster sampling when logistics and cost are your main concern, and population data is hard to access individually. Now, what are the conditions under which cluster sampling is more appropriate than single random sampling? Under the following conditions, when the population is already organized into groups, for example, schools or neighborhoods or geographic regions, cluster sampling becomes more efficient. Example, a survey of students in a country might select entire schools clusters instead of individual students. In terms of the condition of cost or time constraint, when it is logistically or financially practical to randomly sample individuals across a wide area, it's often more feasible to sample entire clusters located in fewer locations. So cluster sampling reduces travel and administrative costs. If it's hard to get a full list of all individuals in the population, then it's easy to get a list of clusters. Cluster sampling is more viable. For example, it might be easy to get a list of hospitals rather than a list of all patients. This is what I mean. And the research focus on group level characteristics. This means that if the goal to understand characteristics at the group level, for example, average test scores across schools, then cluster sampling is appropriate. High within cluster homogeneity. Cluster sampling can still be valid when individuals in a cluster are similar, but this reduces the statistical efficiency. It's more obviously effective when clusters are internally diverse but similar to each other, though this is rare. So in summary, we could say that cluster sampling is preferred when practical considerations outweigh the increased statistical precision or simple random sampling, particularly in large or geographically dispersed populations. So all these things that we mentioned so far, it was about probability sampling techniques, and now we are moving on with no probability sampling techniques. One category is convenience sampling. What is convenience sampling? So non-probability sample techniques includes this we can see here: convenience, judgment, or purposive sampling, quota, and snowball. Convenience sampling is a non-probability sampling method where participants are selected based on their availability and their willingness to participate in the study rather than through random selection. So it's fast, it's easy, it's inexpensive. There's no guarantee that this sample represents the whole population, of course, and it's often used in exploratory or preliminary research. I'll give you an example. A psychology student stands outside the library and asks the first 30 people who walk by to fill out a survey on stress levels. Those people are chosen simply because they are nearby, they're willing to help. This is what we call convenience sampling. When it's appropriate, it's useful when the time budget or budget is limited, when quick preliminary insights are required, and population access is restricted or undefined, when you're going to do qualitative or exploratory research, for example, focus groups or really testing. And the limitations, on the other hand, focus on high risk of bias and no representativeness. The second, that results cannot be generalized to the broader population, and this may exclude important subgroups unintentionally. So what we could say that convenience sampling is practical for quick and easy data collection, especially in early or informal stages of research. However, because it lacks randomization, the findings should be interpreted cautiously and not assumed to reflect the entire population. Now, another category is the snowball sampling. Snowball sampling is this technique when the population is hard to reach or identify. So in this method, initial participants are selected purposefully on purpose, and then they help recruit further participants from their network, and this creates what we call snowball effect. How this works? We start with a few known individuals who fit the study criteria. Then we ask these participants to refer others who they know also fit the criteria, and then we continue this referral process until the desired sample size is reached or no new participants can be found. And when this is snowball sampling is used, when we want to study hidden, hard to reach or rare populations where no complete sampling frame exists, and of course is useful in qualitative research or exploratory studies. Suppose a researcher wants to study the experiences of underground musicians in a city who don't have public profiles or formal memberships. So the researcher might start with a few known musicians. You can ask them to refer other underground musicians they know, and then it repeat the process to expand the sample. This is what we call snowball. So this helps access networks that are otherwise difficult to reach, but may introduce bias because the sample depends on social networks. Now, another category is judgmental or purposive sampling. And how this differs with quota sampling. So first, here the researcher selects participants based on the judgment about who will be the most useful for the study or representative. So selection here is not random. Based on researchers' knowledge or purpose, our goal is to focus on specific individuals that have particular characteristics or expertise that's relevant to our research. Example, when we choose expert doctors to interview about a rare disease because they have unique insights. So this is judgmental sampling. On the other hand, what is quota sampling? The quota sampling, here the researcher sets quotas to ensure that the sample reflects certain characteristics, gender, ethnicity, in specific proportions. Within its quota, participants are usually selected not randomly, but the overall sample matches the population structure of these characteristics. The goal here is to create a sample that resembles the population in terms of key characteristics without random selection. Give you an example. if 40% of a city's population is female, and the researcher ensures that 40% of the sample are female, selecting people who fit that quota until it is filled. So what is a summary of these differences? In terms of selection basis, judgmental sampling, researcher judgment here on who is relevant. On the other hand, the quota sample try to meet predefined quotas by characteristics. In terms of purpose, the first one focuses on specific characteristics. Quota sampling represents population proportions. The first one is no random within quotas, with quota sampling. And in terms of representativeness, the first one is not necessarily representative. The other one aims to be representative on key characteristics. So now, what are the limitations of no probability sampling methods in general? Actually, these methods are used when random sampling is impractical, but of course, they have several important limitations. First, the sampling may not reflect the broad population, leading to biased results. So certain groups may be overrepresented or underrepresented, so lack of representativeness. Second, because participants are not chosen randomly, you can't confidently generalize findings to the whole population. Then researchers' choices of participant availability can introduce selection bias or volunteer bias, so high risk of bias, and no probability of selection known. Unlike probability sampling, you don't know the likelihood that each member of the population is selected, something that, of course, limits statistical validity. And, of course, since the sample is not random, it's hard or impossible to calculate what we call confidence intervals or margins of error, so difficult to measure sampling error. Results from no probability samples are often not suitable for inferential statistics or hypothesis testing in rigorous research, so it has limited use in hypothesis testing. And studies using no probability sampling may be seen as less reliable or less credible or less objective, especially in academic or scientific research. So, so far we have seen these categories, and no probability sampling in general, like what I want to say, no probability sampling can be acceptable in exploratory research, in pilot studies, or what else, in hard-to-reach populations that we mentioned about snowbird population, and time or resource constraint situations. Now, there's another category, what we call multi-stage sampling, and how this differs from cluster sampling, because multi-stage sampling is a complex form of sampling that actually involves selecting samples in multiple stages, usually combining different sampling techniques, big clusters, then random sampling within these clusters. It's often used when we want to deal with large geographically spread populations, but listing every individual is impractical. We can take an example here. A national education researcher wants to study the academic performance of high school students across the country. So the first stage is that he randomly selects a state, this is the first level. So then within each selected state, he randomly chooses two districts. Within each district, he randomly selects schools, and within each schools, a school randomly selects students. This is how this works. This layered approach, it's a layered approach, makes large-scale research more manageable and, of course, cost-effective. So, what's the difference between cluster sampling? Cluster sampling involves divide the population to clusters, said before, usually based on geography, and randomly selecting entire clusters. Then all individuals within the chosen clusters are included in the sample. So the key differences between multi-stage and cluster sampling is the sampling is done in several stages. Cluster sampling is here there is a random selection of all clusters only. A multi-stage sampling selects a subset from within clusters. Cluster sampling includes all members in selected clusters. Multi-stage sampling is more flexible, customizable. The other one is simpler but less flexible. Multi-stage sampling is more efficient for large populations. The other one is simpler for moderately sized populations. And multi-stage sampling is often more cost-effective long term. The other one is cheaper in the short term. So in summary, we could say that multi-stage sampling breaks down sampling into steps, often using different methods at each stage. And cluster sampling selects entire groups and studies everyone within them. Multi-stage is more refined and flexible, while cluster is more straightforward and fast. Now, if we want to describe the process of multi-stage sampling with a real-world example. Here we can take this example. The Ministry of Health wants to study the dietary habits of adults in India. So what would be, this is the research scenario. And in this research scenario, we want to apply the process of multi-stage sampling. What we will do? First, we divide the country into regions. The entire country is divided into states, into zones. We know it's north, south, east, etc. So a random sample of 5 states is selected. Okay, random sample of 5 states. Second step, select districts within its state. From each selected state, we can randomly select 3 districts. Now the sample includes what? Includes 15 districts, 5 states multiplied by 3 states and districts each. Then third stage, we select towns, villages in each district. Within each selected district, we randomly pick 2 towns or villages. So the total is 30 towns, villages, 15 districts multiplied by 2 each. Fourth step, we select households. So it's a 4 states. In each town or village, we list households and we randomly select 10 households. So totally we have 300 households, 30 locations multiplied by 10 households. And the fifth step, we select respondents within household, the final stage. In each selected household, we randomly choose 1 adult to interview. So why we use multi-stage sampling here? Why? Because the population is too large and scattered to list every individual. It is more manageable, more cost-effective and organized, and because each stage narrows down the population, making sampling realistic. So multi-stage sampling allows actually researchers to work through layers of population groups, make it ideal for national or regional studies. This approach saves time, reduces cost, and maintains randomness and representation when full population data isn't easily accessible. And what are the advantages? That is what I said before. It's cost-effective, it's logistically manageable, it's useful where no complete sampling frame exists, it increases efficiency. Advantages when we use it in nationwide surveys, yes, it has a flexible design, it minimizes no response bias of field survey. So for nationwide surveys, it's ideal. Another example in nationwide survey, when, for example, we want to select randomly select provinces, then within each province we select districts, within each district we randomly choose villages, from each neighborhood we randomly select households. It's again another example. So if we want to compare now multi-stage sampling with stratified sampling in terms of structure and application, what we can see here, what we can see is that and the sampling method involves selecting samples in 2 or more stages. So often we use different techniques at each stage. On the other hand, stratified sampling, here the population is divided into subgroups and samples are drawn from each stratum. In terms of structure, the first one is hierarchical, sequential. So sample is selected from larger to smaller units at the stage. On the other hand, simplified sampling is segmented. Entire population is divided into strata based on certain characteristics. In terms of purpose, the first one is useful for large dispersed populations, geographically dispersed populations. When if you want to list those individuals, it's not practical. And on the other hand, stratified sampling ensures that each subgroup is proportionally or equally represented in the sample. The first one is more practical, cost-effective. The other one is more statistically efficient. When strata are homogeneous internally and heterogeneous between. The first one, we can mention the case of National Education Survey. When we select regions, when we select schools, when we select the students. The stratified sampling, here we can give an example of an income level study, or when we divide the population into low, middle, high income, then sample from each group. And in terms of complexity, this is more complex because this is due to multiple stages and various sampling methods. The other one is less complex. And multi-stage sampling, of course, it presents high risks. The other one has lower risk. So this is the comparison, more or less, between the multi-stage sampling, the stratified sampling. I think it's easy to understand. And another application we can see here has to do with survey and college student stress levels. How to choose here a sampling method? If you want to conduct a survey on college student stress level, the best sampling method would depend on what? Would depend on the research goals, on the resources, and the desired accuracy. So, what we can recommend here, recommended method is stratified random sampling. Why this method? Because stratified random sampling involves dividing the student population into subgroups, strata, based on certain characteristics, relevant characteristics, for example, year of study, gender, or academic program, and then randomly selecting students from each group proportionally. For example, we divide students into 4 strata: freshmen, sophomores, juniors, and seniors. Then we randomly select an equal number of proportionate number of students from each group. And of course, what are the benefits of this? This ensures representation of all key groups. This improves accuracy and reliability of our results. It helps identify patterns of variations within subgroups, and this reduces sampling bias compared to convenience sampling. Now, we could have alternative methods. For example, you can use convenience sampling if you want to ask, for example, students around campus or online, which is quick, but as I said before, it's not representative. Or you can use simple random sampling as alternative method if you have full access to a full student list, and then randomly you select names. It is fair, but it may miss subgroup differences. So in order to get a meaningful, representative, detailed insight into college student stress here, stratified random sampling, I think, is the best suitable method because it balances fairness, accuracy, and comparability across student types. Now, if you want to design a stratified sampling plan for a study on employee satisfaction in a multinational company, then what do you do? In order to ensure that the sample accurately reflects the diversity of employees across regions, then departments or roles, stratified sampling is an excellent choice because here we define the population. We can identify the total population of employees in the multinational company. This includes all employees across different countries, departments, job roles, and levels. Then we identify the stratification criteria. We decide which characteristics are more relevant for stratification. Common options for an employee satisfaction study might include geographical region, the department, the job level, mid-level, for example, entry-level, deployment type, full-time, part-time. So you can choose one or combine two levels for a more nuanced certification, of course. And then we divide the population into mutually exclusive and collectively exhaustive strata based on the chosen criteria. For example, Stratum 1, we have IT employees in North America. Stratum 2, we have sales employees in Europe. Then we have HR employees in Asia, etc. In step 4, we define a sample size for each stratum. There are two common approaches here. What we call, the first one is proportional allocation, when sample size in each stratum is proportional to the stratum size in the population. Proportional allocation, the first one, and the second one, equal allocation. Sample size from each stratum is useful if strata are small or equally important. Then we randomly select individuals in each stratum. We use random sampling or systematic sampling within each stratum to select participants fairly and without bias. Of course, then we collect data, we distribute employee satisfaction surveys to the selected individuals from each stratum, and we analyze the results stratified by group. This allows for comparisons between groups, departments, or roles, helping the company identify satisfaction trends and target improvements. So here, if a company has 10,000 employees across 5 regions and 4 departments, and we want to get a sample of 1,000, what will we do? We will stratify by region department, so 20 strata. Then we allocate sample sizes proportionally, and then we randomly sample within each group. This approach ensures what? It ensures that all relevant subgroups are fairly represented, leading to more accurate and more actionable insights into employee satisfaction. In a situation now where the population is unknown, which sampling technique would be most appropriate? Usually here, the most appropriate sampling techniques are typically no probability sampling method, since we can create a full sampling frame for random selection. So the best options could be combined sampling, or we select individuals who are easily accessible to researcher. This is useful for quick low-cost studies, for pilot studies, or when we want, for example, to survey people at a mall or students in a class. Of course, the limitations have to do with low generalizability or high risk of bias. The second one with Snowball, we said before that when we have existing participants who recruit future participants from the network, it's useful when we want to study, as I mentioned before, hard to reach or hidden populations. That could be drug users, that could be undocumented workers or niche professionals. Its strength is that it's effective when the population is unknown or difficult to access, but the limitation is that the sample may be biased towards social networks. Another option here, which will be appropriate, is the judgmental or proposed sampling when researchers select individuals who are most relevant to the study. This is useful for qualitative research for expert opinions. This focuses on individuals with specific knowledge or characteristics, and the limitation is that it is subject to researcher bias. And quota sampling, when researcher fills quotas for key characteristics without random selection, and when to use when population structure is partially known, but full list is unavailable. So what is the strength? The strength is that it mimics population structure in key characteristics, and the limitation that is still no random possible, also with possible selection bias. So here you can see which is sample method is suitable when population is known, what are the key benefits. So what we explained now, the Vini sampling is fast and easy. Snowball sampling reaches hidden populations. Proposed sampling targets specific relevant people, what we think that is more suitable for our research. And quota sampling partially, because this actually ensures balance in known characteristics. So if the goal is exploration or qualitative insights, then Snowball or proposed sampling is ideal. If you need broad opinions quickly, then convenience or quota sampling may work best. Now, if you want to suppose you are conducting research on education quality across a country. How would you apply a multi-stage sampling to ensure efficiency representativeness? When we conduct a nationwide research on education quality using what I said before, using multi-stage sampling is ideal because it ensures efficiency. Efficiency means manageable scope and representativeness, so coverage of various regions, school types, and demographics. So what we can do here in this example, we can divide the count into regions and states. We organize the count into large units. Then we randomly select a sample of regions or states to include in the study. What is the goal here? The goal is to ensure that geographic diversity and broad national coverage is here. Then we select districts within each region. In each region state, we randomly choose several districts. Number of districts per region may be based on population or school density. So the goal in this stage is to capture rural, urban, or semi-urban educational environments. Third step, we choose schools within each district. From each chosen district, we create a list of schools, public and private schools. So we use stratified or random sampling to select schools from different types and levels, primary, secondary. And the goal in this stage is to represent the different school types and education levels. Finally, we select students or teachers within schools. In each selected school, we randomly select students or teachers to participate in surveys and interviews or assessment. Then our goal here is to collect direct diverse data on educational experiences and teaching quality. So an example scenario, if you want to survey teacher qualification, student performance, we select 5 states out of 28 using random sampling. In each state, we choose 3 districts. In each district, you pick 4 schools. In each school, you select 10 teachers and 20 students. So why multi-stage sampling works well here? It works well because it reduces the cost and time compared to serving every school, because it covers different regions and socioeconomic backgrounds, different school types, and because it allows adjustment at each stage depending on available data and logistics. So, in this example, to research education quality across a country, you need to use this multi-stage sampling to break down the population into manageable logical units. By sampling regions, districts, schools, individuals, what do you manage to do? You balance representativeness and efficiency, ensuring that your findings reflect the true state of education across diverse areas. And if you want to design a multi-stage sampling plan for a health survey in rural and urban areas, the same way, we can define the population, all residents in both rural and urban areas within the target region, for example, county or state. Then we divide the population into two broad strata, rural areas and urban areas. Within each stratum, we identify primary sampling units such as districts or blocks, and we randomly select a sample of primary sampling unit from rural and urban strata proportionally or equally, depending on our study design. Then, within each selected primary sampling unit, we list smaller units, such as villages, in rural primary sampling units in neighborhoods, in urban primary sampling units, and randomly select a sample of these smaller units. So we select the secondary sampling units. Third step is to select the household. Within each selected village or neighborhood, we prepare a list of households. We use systematic or semi-random sampling to select households for a survey. And the last stage, we select individuals. Within each selected household, we can list eligible individuals, for example, adults or children, depending on our survey focus. We randomly select one or more individuals to participate in our health survey. So here you can see the stage, the unit sampling method. The first stage, we have random samplings. For the secondary also sampling unit, we have random sampling. then for household systematic random sampling, and for individuals with a household random selection. So what are the advantages of these? Advantages is that it's practical and cost-effective for large diverse populations, that this allows separate analysis of rural and urban areas, and that it is flexible at each stage, depending on available data and resources. And this plan ensures representative coverage of both rural and urban populations while making the survey logistically feasible. If you want to think about or think more about this issue, you need to discuss the trade-off between cost and accuracy in sampling techniques. When we select a sampling method, researchers must often balance the cost and accuracy. Cost and accuracy, there are two competing priorities in research design. The cost considerations, low-cost methods are convenient sampling, quota sampling. The quick and inexpensive, but often less reliable, said before. High-cost methods are stratified and multi-stage sampling because they require more planning, because of they need access to population data and logistics, but they offer high accuracy. The accuracy considerations, because accuracy refers to how well the sample represents the entire population, and this reduces, of course, the bias. High accuracy methods is when we use randomization, or when we need to, of course, ensure representativeness across key subgroups. And on the other hand, we have low accuracy methods, which rely on no probability techniques, prone to selection bias and limited generalizability. So the trade-off, how this is explained, in terms of cost, for example, we have low-cost sampling, which is the low here, the cost, high cost for high accuracy sampling. In terms of time, of bias risk, generalizability is weaker for low-cost sampling, is strong with high accuracy sampling. The use case, the low-cost sampling is used in exploratory and formal research, and high accuracy sampling for formal large-scale or policy-forming studies. So, why might researchers choose a no probability sample, even if a probability sample is feasible, is a common question. Here, for several practical or strategic or methodological reasons. First, to gain a depth insight, but not to generalize to a larger population. And why no probability here? Because we focus on rich, detailed understanding from a smaller, purposefully chosen group, that would be expert interviews or focus group. Probability sampling can be expensive, said before. No probability sampling, like convenience, are faster. Even if theoretically it's feasible, a complete sampling frame might not be accessible due to privacy, logistics, or institutional barriers, or limited access to full population. In cases where the population is small, hidden, or stigmatized, noble or purposive sampling may be more practical or ethical. And for pilot studies, because for pre-testing questionnaires or trial runs of a study, no probability samples are often used to refine tools before a full-scale study. Resource constraints, of course, when representativeness is less critical in some marketing or social research, the goal is, for example, to gather quick insights or trends, not to statistically represent the population. So a researcher may intentionally choose a no-probability sample for reasons of depth, of speed, of cost, of practicality, or research focus, even when a probability sample is technically possible. The trade-off is less generalizability in exchange for greater feasibility or detail. And of course, if we discuss advantages of multi-stage sampling mentioned before, mentioned that it's more flexible, it's time-saving, it improves field management. Disadvantages have to do with more sampling errors, complex design analysis, the risk of bias, and equal representation. In large-scale studies, we measure nationwide studies, we measure that it's more practical than simple random sampling because it reduces logistical complexity, it adapts to large, diverse population. It's easier to implement without a complete sampling frame. So you can see here example of comparison. The sampling is complex and scattered. The multi-stage is structured and localized. Its sample random is low, has low level of practicality, high level of practicality with multi-stage sampling. And finally, before concluding, we can say that in multi-sampling stage, how we can manage the sampling error by, for example, using random sampling at each stage. So how to do it? By avoiding convenience or judgmental sampling at any stage. By increasing sample size, large samples reduce variability and improve precision. How to do it? By using statistical formulas to determine optimal size at each stage, considering design effect. Try to stratify before sampling. Stratify clusters by region or income or size before selecting them. Why it matters? Because stratification before each stage ensures more balanced samples. And ensure adequate cluster representation. Select a sufficient number of clusters, ensure that they vary across characteristics. Control design effect. Choose diverse clusters or adjust the sample size based on design effect. Why it is important? Because the more similar people within clusters are, the greater the error. And using weighting adjustments, apply post-sampling weights based on population proportions. Run a small pilot study to fine-tune your sampling strategy, because this helps identify potential errors designed before full-scale sampling. And in the three-stage example, for instance, we select 20 districts randomly. Within this district, we select 5 schools randomly. Within each school, select 10 students randomly. And managing errors involves what we ensure all selections are random. We choose a large enough number of districts and schools that we possibly stratify districts by rural and urban status, and that we adjust for clustering in statistical analysis. So, by concluding, about ethics, we have explored this in previous sessions, that it's very important to inform consent, issues of privacy, confidentiality, the unequal burden on risk, the exploitation of valuable groups. Sampling should not exploit individuals or communities. And the bias, we need to know all these definitions: selection or response bias, voluntary response bias, other coverage bias. So how to minimize? We mentioned about conducting pilot testing, weighting the data, using random sampling, stratifying the sample, increasing response rates, creating comprehensive sampling plan and frame. And these ethical considerations.
So how to minimize?
Yes.
We mentioned about conducting pilot testing, weighting the data, using random samples, stratifying the sample.
Yes. So,
yeah. Okay. Sorry.
Yes.
Okay. Yes, amazing. You are done? Yeah.
Yes, yes.
Okay.
I'm trying here to stop it, but
you can remove the slide from.
Yes, I'm trying, but this has changed a little bit, and
or just go to the 3 dots and remove it.
Okay, perfect.
Okay, thanks.
So I think we have done. We don't need a second part. We managed with practical applications.
We have finished the whole thing, or next week we have
yes. No, there won't be.
Yeah, very. I see that. I was really amazed to see the a beautiful slides where it's clearly mentioned about sampling. It's indeed an interesting topic, in research, because it's also very a crucial topic, because without sampling, without proper sampling, the right sampling, you will not be able to come up with the good results. Yeah, am I right?
Yes, exactly.
Yeah, so it is really wonderful. Yes.
I think the practical applications were very interesting. Yeah. So someone wants to see again the video in order to see how we can, go step by step with each category, with each sampling.
Very well presented, everything narrated accordingly, and very systematic, and I'm very sure our audience would have gained much from, as usual, would have gained much. And this topic, I don't see why, if our audience have problem in understanding, because it is very, very clearly presented, So all you need to know is that just go into applying, just pick from here and apply in whatever you do. It's so easy. Yeah. So, okay. Thank you so much, Ambassador Professor Dr. Rania Lampu. Thank you so much for your wonderful, brilliant presentation as usual. And I thank our wonderful audience and a very supportive audience who are always with us. And I'm happy if you have gained much from this presentation, because we spend our time and energy, for you all, because you are with us and we are always with you. Thank you so much. We'll meet again next Thursday with another interesting topic. Thank you.